So event organizers normally don't take the stage for themselves, but we thought we could do that as a kind of special treat, well, for ourselves and hopefully for you as well, just to show you what it is that we do when we're not actually organizing this event and how we actually use this technology ourselves and why, in that sense, we consider ourselves, member of the community that we are addressing. So today I'm here to present to you what I call the year of the graph. And actually the first thing to mention in that is where the term is coming from, right? So it's coming from basically an article I wrote at some point, which, as some of you may know, as again, when I'm not organizing this event, I run a consultancy, which is called Linked Data Orchestration. And I'm also a contributor for ZDNet. So wearing my ZDNet hat, I wrote an article in early 2018, which was called The Year of the Graph. And it was, before the whole hype started. And it kind of set the tone. So I thought, this is important enough to have its own home. And therefore, at some point, I created a website called Year of the Graph, which aggregates a number of things. So many of the things that I'm going to talk to you about today are featured there as well. So since I keep an eye on this technology, I thought it's worth sharing findings with the world. So I also do a newsletter, which is called The Year of the Graph, which is published every couple of months. And I also share these findings on a daily basis, actually, on social media. So if you want to keep up with that, you can follow me on Twitter, or you can look up The Year of the Graph on LinkedIn. And last but not least, there is a graph database report, but I'm going to share more about that when we get to the part about graph databases. So let's see what is graph to begin with. The way I think about it, it's a number of things. So I have divided graph into 4 categories: graph analytics, knowledge graphs, graph databases, and graph AI. And I'm going to refer to them, well, in order of appearance, let's say. This is how I first came to be connected with those, and I think this may be the case for other people as well. So graph analytics, this is actually the oldest part of graph, and it dates back to the 18th century, actually. So this is when a famous mathematician called Euler first came across the problem of trying to model how to go from point to point, basically. This is known as the bridges of Königsberg problem, and there's a direct link from that to modern data science. So when we talk about graph analytics, we basically talk about a number of algorithms that help us do interesting things with graph. So we have search and pathfinding algorithms. Search enables us to explore a graph, either for general discovery or for searching explicitly for something. And one example where this may be useful is when you're trying to find neighbors in a network. Pathfinding, on the other hand, has to do with exploring routes between nodes. And an example of where this is useful is obviously when you're trying to find your way, so navigation. Another interesting class of graph algorithms is centrality. We have probably the most famous graph algorithm belongs in that category, so PageRank. We also have closeness, betweenness, and degree algorithms. And what we're trying to do with centrality is to understand the roles of particular nodes in a graph and their impact on the network. And one example is that we can use this type of algorithm to find influence, and PageRank is actually a very good example of that. Last and not least, the final category in graph algorithms is community detections. Community detection. This class of algorithms was, to a large extent at least, derived to study social networks. So hence the name as well. It has to do with identifying related sets to reveal clusters of nodes, isolated groups, and network structure. So in this class of algorithms, we have algorithms such as components and connected components, Leven, and so on and so forth. different variations. A typical example and a very common one of what these algorithms are used for are what we call fraud rings or fraud analysis. So trying to identify, using the connections in networks to identify possible collusion. And kind of well-known use case on graph analytics, AstraZeneca, but actually lots of pharma companies use graph analytics for drug discovery, which is actually a very timely topic as well. So with that, we come to the second class of graphs, so knowledge graphs, basically. So if you attended the previous talk, which was about the semantic web, you know that there is a direct link going from Tim Berners-Lee to Google and beyond. So we referred earlier to the semantic web stack, and part of that actually is very much connected to graphs. So Google has a lot to do with this kind of renaissance we see in graph today. So obviously, you know, the web is a graph as well, because we have documents and links, and you know, it's kind of natural way to model that. And Google itself obviously benefited a lot by investing in a graph algorithm called PageRank, which is what gave it its edge, basically. However, there came a point where even Google realized that if you want to categorize content on a web scale, you need more than clever algorithms. You need metadata and you need semantics. And this is the point where Google actually adopted semantic web technology and coined the term knowledge graph. And this was a kind of tipping point because it basically signified the wider interest in this kind of technology. The thing is that, and you know, the most famous example that pretty much everyone would be familiar with, or at least in this audience, is Schema.org. And this is basically Google's and other, it's not just Google, it's other search engine vendors that collaborate in that, but it's basically a kind of schema for the web, which enables a number of very interesting things to happen. It picks up markup, it enables semantic search engine optimization. And basically it's what feeds Google's big knowledge graph. And it's also, I should also add that it's the source of some confusion, because to many people, the fact that Google uses that and it actually names this kind of information panels that we get to see on our results page as knowledge graphs makes these people think that this is what a knowledge graph is about. Technically, this is actually a result which is based on a knowledge graph, but it's not a knowledge graph per se. Regardless, besides Google, pretty much everyone seems to have a knowledge graph these days. And I mean, from Morgan Stanley to the average user. And just as a side note here, personal knowledge graphs is a very, very interesting area, and something that you will be hearing more about in the near future. So let's define semantics a little bit, because knowledge graphs are actually about semantics. So when we start talking about semantics, there are different layers that we can do that. The most fundamental level is what we call the controlled vocabulary. So basically, a number of terms that around which there is some consensus. This is the easiest way to think about it. So a tag set is also a controlled vocabulary, for example. As long as we agree that these are the terms that we use and this is how we use them, it's a controlled vocabulary. The next level is a taxonomy, which is basically a controlled vocabulary plus hierarchy. So you can have layers, basically. And then the next level is an ontology, which is a taxonomy, so controlled vocabulary plus hierarchy, plus, in the case of ontology, other types of relationships. So not just hierarchical relationships, but arbitrary relationships, basically, plus logic maybe, but that's a whole different area. And finally, a knowledge graph, as we also mentioned in the previous talk, the distinction between an ontology and a knowledge graph is not entirely clear, but if there's a simple way to think about it, you can think of it as the ontology being the schema and the knowledge graph being the populated schema. So schema plus instance data, basically. It's very simplistic, but that's the simplest way you can think about it. So to wrap up with knowledge graphs, A knowledge graph, I would like to point out, is basically a way of doing AI.
George,
yeah?
I'm sorry to briefly interrupt. Members of the audience say that we haven't moved the slides, that the first slide is still on the screen. So I don't know if you
would
like to... Great.
Is it moving now?
Please let us know if everything is okay now. Please go on. Sorry for the interruption.
Yeah, no, thank you. Well, I would like to take the opportunity, by the way, to let you know that all the slide deck will be shared after the talk, so no worries. I'm sorry you missed part of it, but it's okay. Hopefully, my narrative kind of made up for it. Anyways, I was just talking about how a knowledge graph, which is, as we mentioned, very much connected to an ontology, is actually a way of doing AI. And to quote here Mark Hall, who's the executive director of Morgan Stanley, Mark Hall said that, well, traditional data modeling has concerned itself primarily with capturing and retrieving data. Ontology, on the other hand, concerns itself with a shared understanding of what that data means. So the point that Mark Hall wanted to make was that before embarking on your AI journey, it's critical to ensure that you understand and document your domain. There's more to that, as we'll see when you get to the part about Graph AI, but this is something to keep in mind. And to give you an example of a well-known use case for knowledge graphs, and to stick to what we have presented here in Connected Data London, Zalando, who's a leading retailer in the German-speaking countries with millions and millions of active daily users. They are using an ontology in the backend to improve coverage, response time, and the bottom line. So getting to the next category of where graphs are used, and the one that I have dedicated special attention to, graph databases, which are about leveraging connections. So if you can see the slides, hopefully you can see them now. What you're seeing here is a kind of visual to classify graph databases along different dimensions. And there's different ways of thinking about graph databases, and I'm going to refer to some of them. But before I do, I wanted to give a little bit of warning. So when it comes to graph databases, mind the hype. What I mean by that is that, well, if you go to database engines, for example, you can see that, it's the most trending database category, has been the most trending database category for the last couple of years at least. And compared to other categories, it's very clearly on the rising curve. However, and there's very good reasons for that, which basically have to do with the fact that as your data grow in volume, volume starts in a way becoming less important, and what becomes more important is connections and how your data is connected. And if you want to explore that, a graph database is the biggest, the most appropriate way to do that. That said, however, it doesn't mean that you should use a graph database just because everyone else is, or regardless of what the problem you're trying to solve is, basically. And a very good way of putting that has been framed by Denise Kostnell in her book, The Practitioner's Guide to Graph Data, when she basically said, well, does your problem need graph data? If yes, well, the answer is clear. There you go. Go get a graph database and, start thinking in terms of graph. And the key question to ask is, do relationships within and across your data help you understand your problem? Again, if the answer is yes, fine, go ahead. The only question you have to answer, which is a very big and specific and important one actually, but that's a different thing, is which graph database is right for you. But if not, you shouldn't be blindly adopting it. So I briefly referred to the question of how do you choose a graph database, and actually what is a graph database? And that may seem like a trivial question to ask, but it's actually not. And the reason it's not is, well, precisely because of the hype. Let's just say that some database vendors have been overly eager to present their products as being a graph database. And in my humble opinion, that's not always the case. So The first category we examined was graph analytics, and graph analytics in and by themselves are very, very useful. However, if you take, any database and add an analytics layer on top of that, does that make it a graph database? Well, no, it doesn't. Because in order to call a database a graph database, it means that it should have a fully fledged graph API. In other words, you should be able to both write and read graph data. If you write relational data and then you use some kind of analytics framework to analyze that data, well, that's a relational database and a graph analytics framework. It's not a graph database. I mean, it's quite simple, actually. Some other important distinction is between operational and analytical databases, and some graph databases are better than others in these departments, as happens with basically any kind of database. And another useful distinction to make is, well, native versus non-native databases. Again, this is a quite nuanced topic, but let's just say, broadly speaking, that some databases are designed and built from the ground up to work purely as a graph database, and you can call them native graph databases. Others, on the other hand, are what we call multi-model databases. So they may support, I don't know, relational or document or columnar or whatever other format plus graph. So these are not native graph databases in that sense. That doesn't make them, better or worse. It just makes them different. And this is a distinction you should have in mind if you go out in the market for a graph database. Another very useful distinction to make when we talk about graph databases is their data model. So we have two main camps, let's say there. On the one hand, we have property graph databases, which are, let's put it again simplistically, probably easier to work with, but they also have their own limitations, like lack of standardization, for example, even though I have to say in advance that these two camps are getting closer and closer these days, and actually standardization is being pursued, and hopefully we'll see more of that in the future. However, that said, property graph databases generally do better in operational applications, graph analytics, and AI, a certain type of AI, because this is, again, a broad category. RDF, graph databases, on the other hand, RDF is the other data model we have when modeling graphs, typically do better in data integration, knowledge graph scenarios, and AI, albeit a different kind of AI, so more the symbolic type, while property graph databases do a little bit better usually in machine learning scenarios. So to wrap up again this category with an example of graph database in use by a very well-known client, we have Telia, which is the leading telecom company in the Nordics, which serves more than 1.5 million homes and does have a real-time processing application based on a graph database. And last but not least, we have Graph AI. So this is in part what has inspired me to call Graph the future of the future, since people say that AI is the future. Well, Graph is in some ways the future of AI, or at least this kind of machine learning based AI that most people actually mean when they refer to AI today. So you could, by induction say that Graph is the future of the future. So there's different ways that this interplay between graph and AI manifests itself. So the first way is by this two-way connection between graph analytics and machine learning. So when we have graph analytics, we can compute certain graph metrics, which may be added to machine learning models to help us build machine learning predictive models using metrics based on graph analytics, which is, basically adding extra features to your machine learning model. This can also work both ways, however. So when you have built a model and used it to score or classify data, you can take that data and add it to a graph whether it's your original graph or some new graph that you create. So you see how this interplay between these approaches, how graph analytics feeds machine learning and vice versa. Another interesting point that graph cuts across AI is in terms of neural networks. So this is an area which is seeing very, very big growth and research breakthroughs in the last years. Graph neural networks, which are models that capture dependence of graphs via message passing between nodes of the graph. So the difference between graph neural networks and standard neural networks is that graph neural networks retain a state that can represent information from its neighborhood with arbitrary depth. There's different ways of structuring graph neural networks, and there's more added, I would say, almost every day. However, the takeaway from this part is what makes a difference is the fact that you can have a sort of memory. And in that way, you can embed some kind of domain knowledge, which can effectively help deep learning system bootstrap by encoding primitives instead of forcing the model to learn from scratch. And with that, we come to the last part of how graphs and AI intersect, which is graph embeddings. So embeddings in general is a method that is used to reduce dimensions of input to feed that machine learning algorithms. Typically, up to now, at least, it has been applied to text. So we have text embeddings, which can take a whole document and reduce it to a sentence or even a word. And the same kind of principle can be applied to graphs. And graphs have an extra feature, which is that graph data are discrete. So graph embeddings pre-process graphs to turn them into a continuous vector space, which is what what machine learning algorithms needs to work with. So, and there's different ways of doing that. So we have walk embedding methods that perform graph traversals with the goal of preserving structure. And we have proximity embedding methods that use deep learning and proximity loss functions to optimize proximity. There's more, but this is a very, very nuanced topic. So I'm obviously just scratching the surface here. And famous use case here is China Mobile, one of the biggest mobile operators in the world, actually, that does anti-fraud in real time using graph machine learning. So wrapping up, and this is a very huge topic, and I'm very aware of the fact that we have only just touched the surface. Graphs are everywhere, and they're in hype cycles. So it's been a couple of years already since Gartner included that in the upward slope of emerging technologies. All the big technology companies of the world are adopting it, and it's trickling down to adoption by smaller players and actually even by individuals by now. So if you want to keep up with that, which is what I'm trying to do as well, again, just to recap, you can visit the yearofthegraph.xyz, which is the home for all these resources. And from there, you can navigate to the newsletter and the graph database report. Or if you want to have like a daily news feed, you can follow me on Twitter or look up the Year of the Graph on LinkedIn. Thank you. And let's see if we have any questions. Just going through the chat box now. Okay, I see one question from Hamad, which is whether Time Mobile is doing AI graph, if I got it correct. And the answer is yes. And I know that directly from the vendor who worked with China Mobile. I'm not going to share which vendor it is, but I'm sure if you look around a little bit, you can find it. So yes, they are using machine learning on graphs in real time actually to do fraud detection. And since it's working for them, one of the biggest vendors in the world, it's kind of safe to assume that it can work for others as well. Another question I see here is on recommendations on which tools to start playing with for personal knowledge graphs. This is actually something which is very near and dear to my heart. It's hard to give you something right away, but what I can tell you is that this is something that I'm working on with a group of people, actually. So we'll be sharing more resources on that soon. So again, I would advise to, if you want to stay in touch, either join the newsletter or follow me or the Year of the Graph on social media, and you'll be notified when the time is right to publish something on that. I see there's more questions actually popping up right now, but I'm only going to be able to quickly take one because we'll have to wrap up since there's another presentation coming up at 7:30, so in about 5 minutes. Let's see. So, is there any use case of graphs for industrial IoT? Well, yes, of course there is. Actually, the use case I referred to earlier, so Telia, the telecom company from the Nordics, their use case is actually IoT. So to give you a little bit more of background, what they do is they work like many telecom companies do. Telia does provide a router as well. So they have developed an application that lets you connect different sensors in your home to this router. And so what the router does is that it aggregates the information coming from these sensors and tries to do a little bit of monitoring plus a little bit of smart, let's say, applications such as, locking or unlocking doors and this kind of thing. So with that, just to give our next presenter, our own James Fair, the time to properly set up, I will have to wrap up. And thank you everyone for your questions. Rest assured that we'll be taking them and we'll try to answer them all offline. Thank you very much, and well, see you all in a bit in James's talk. Bye from me.